Bismillah ar-Rahman ar-Rahim. Uh, Last time we stopped at the discussion of the factors controlling seismic velocity. This means how seismic velocity change with the geologic condition as we move from the surface down to the depths of investigation for our seismic survey. So we have many factors that can affect our seismic record, our seismic data, our seismic velocity. These are four main factors: the porosity of the sedimentary rocks, the temperature, the pressure, and the mineral composition of this rock. Usually, the porosity is effective until the depth of 10 kilometers, and the temperature usually change from as a gradient from 0.4 to 0.56 meter per second per 1 degree Celsius. The pressure also changes with Pascal by from approximately 0.2 to 10 to the power minus 3 per kilometer per second per MBA. And then the mineral composition. The last one, the mineral composition, actually affect the elastic properties. And seismic velocity is a mechanical wave that is directly related to the elastic properties. That's why it's sometimes called the elastic properties or the elastic waves. Uh, Generally speaking, velocity increases with depths in sedimentary rocks. As you can see here in this diagram, the various type of velocities, either P wave or S wave, increase with depths because as we go deeper in the subsurface, the compaction of the sedimentary rocks becomes better and higher, and then the elastic properties becomes higher, and this lead to also increase, as you can see from this type of curves that shows increase in seismic velocity from 0 depths until about 6 kilometers. And here the seismic velocity for P wave increasing from 5 kilo feet per second to maximum at 15 kilo feet per second or 20 kilo feet per second, as related to the type of rocks. In terms of pressure, the velocity also change with the pore pressure. Usually, the pore pressure, when increase, it will cause decrease in effective pressure and in seismic velocity. Now, the discussion of pressure, we have two types of pressures. Pressure that exerts on the layer from the above layers, that the weight of this layer on the certain layer at certain depths, and the pressure of the pore, the fluid that occupy the pore spaces. When we have the normal condition, usually the pressure that comes from the weight of the overlying beds becomes high, and then the compaction and the effective pressure becomes high, which leads to increase in velocity. But when the pore pressure is occupied with hydrocarbon material, this hydrocarbon material, especially uh, gas, will make increase in the pore pressure. And this increase in the pore pressure will cause effective pressure to be reduced, and consequently the velocity that is related to the elastic property of that rock will be also decrease. And this is one of the criteria that we use to define or to detect the zone of the gas zone of the reservoir, which on the seismic section, as we can see at the towards the end of this study, this course, that there will be inversion of elastic uh, properties, inversion in velocity. Also, this diagram shows the variation in porosity and velocity with depth. So as you can see from this diagram that this is the porosity, and as we go deeper, there is decrease in porosity, as you can see. According this caused by the compaction. When the rock is under huge weight from the overlying layers, that it will be highly compacted. And when it is highly compacted, then the uh, porosity will be decreased and also the velocity will be increased. We can, if we have enough information, say from the well logging, we can use this Atty's law that makes empirical relation between depth and porosity, and also we can get relation between porosity and velocity using this relation, where the uh, the velocity will be the measured velocity, well, 1 over measured velocity, or we can say the slowness, equals rho times the uh, the slowness of the fluid, poor fluid, and then this plus 1 minus phi here is the velocity over the velocity of the matrix. So we have rho here uh, is the density, and phi here is the porosity. So if we have, for example, in our quizzes that we are going to have later on, then we can use this relation. We give some information either to get the porosity if we have other factors, or to get the total uh, velocity if we have these factors like the velocity and the velocity of fluid and density and the matrix velocity. This and this uh, part of our lecture. Thank you for your kind attention. Thank you and Assalamu alaikum.